Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Hydroboration-oxidation with isotopic reagents. In this reaction, the alkene CH3, CH is equal to CH2 undergoes hydroboration using BD3, borne with deuterium, in THF, followed by protodebaronation, protonolysis, using CH3CO2T, tritiated acetic acid, where T is equal to tritium, 3H. Moving on to the next step. BD3 adds across the double bond in a SYN, CIS, addition following anti-Markovnikov regioselectivity. The boron attaches to the less substituted carbon, terminal carbon, C1 is equal to CH2 and deuterium, D, attaches to the more substituted carbon, C2 is equal to CH carbon. This gives CH3, CHD, CH2B, organoborane intermediate, where D is on C2 and B is on C1. And for the final step, the C2B bond is cleaved by the tritiated acid. The boron is replaced by tritium, T, from CH3CO2T. This places T on C1, the terminal carbon where B was attached. Result CH3, CHD, CH2T. C3, methyl CH3, unchanged. C2, CHD, got D from BD3 hydroboration. C1, CH2T, got T from protonolysis with CH3CO2T. Why other options fail? A. CH3, CHD, CH2D. This would result if both steps used deuterium, but the second step uses tritiated acid, CH3CO2T, so T not D is incorporated at C1. B. CH3, CHT, CH2T. This would result if both steps used tritium, but the first step uses BD3, deuterium, so D not T is incorporated at C2. D. CH3, CHT, CH2D. This would require T on C2 and D on C1, which is the reverse of what happens. BD3 delivers D to C2 and CH3CO2T delivers T to C1. Therefore, the correct answer is C. Therefore, the correct answer is option C.